Hello all. As a continuation of my lecture series in transmission and distribution, in the previous video we have clearly discussed about the structure of power system and single line diagram. Whereas in this video we are going to discuss about the transmission line parameters and conductors, different types of conductors. So we talk about transmission lines. So the transmission line, we will be having three parameters. One is resistance, inductance and capacitance. So without these, we will not be able to transfer the power from one place to another. So first we will deal with the resistance. So as we all know, resistor is opposition of current flow. So it resists the flow of current. So that's what we have already, it is a basic Ohm's law, like in resistance we will be having opposing the current. So it is the opposition of line conductors to current flow. So flow of current will be restricted. The resistance is distributed uniformly along the whole length of the line. So that is what is clearly shown in the picture. Like whatever may be the distance or length of the line, the resistance and inductance will be evenly distributed. So R1, R2 and R3 indicates the resistance, L1, L2 and L3 indicates the inductance. So as a combined picture, we have accumulated all the resistance and the inductance value which is mentioned in the second picture. That is sum of R and sum of L, that is sum of resistance and sum of inductance. So any transmission line we will be having a voltage source and a load. So voltage source is Vs, Vr is receiving end voltage and ZL is the indicates the load. So next coming to the inductance. So inductance is when an alternating current flows through a conductor, a changing flux is set up in the conductor. So indicator is change in flux is set up in the conductor. Due to these flux linkages, the conductor possesses inductance. So because of this flux linkage, that conductor will have an inductance. So mathematically, inductance is defined as L is equal to psi divided by I, whereas that psi represents flux linkage in Weber turns and I is current in amperes. So the unit for inductance will be Henry, whereas the unit for resistance will be ohms. So this is another important parameter in the transmission line. So coming to capacitance, so we generally capacitance is we will be having two conductors separated by an insulating material which constitute a capacitor. We call it as dielectric capacitors. So we will be having two capacitor plates inside which we will be having a link. So that is what we call it as capacitance, and they are separated by air insulation. They are separated by air insulation. So the capacitance exists between any two overhead line conductors. The capacitance between the conductors is the charge per unit potential difference. So the unit for capacitance is farad. So next coming to introduction to the conductors. So we talk more about the conductors where the first main parameter is selection of conductor based on the place, and conductivity. We have to check the conductivity, and if we use this conductor, how much will be the losses. So that we should have a calculation before installing that particular conductor, and if we install this particular conductor for this much distance, what will be the cost or what will be the expense. So these four parameters are very important before going for a project. Yes, so the material used for conductor is copper and aluminum. These two materials will be used for a conductor. So this is introduction to the conductor, and coming to the difference between aluminum versus copper. Whereas advantages is aluminum is lower cost, lesser weight, larger diameter, and but one drawback is tensile strength is lower than the copper. A tensile strength of the aluminum is lower than copper. So that is why we prefer copper for the conductor. So coming to types of conductors, we will be having three conductors solid conductors, stranded conductors and bundled conductors. So solid conductor is we will be having only one line as shown in the picture. So the red color is the insulation made up above the conductor in order to avoid accidents. Okay, so it consists of a single piece of metal wire. It is very cheap in manufacturing. It is very suitable for shorter length. For shorter length, we can use solid conductors. So next we are going to deal with stranded conductors, where many solid conductors will be twisted, and as shown in the picture, it consists of many subconductors touch each other. So it is costlier compared to the solid wire, because it is n number of solid wires are used, so it is very little costly, and the size is larger. Next one is bundled conductors. So bundled conductor is, as shown in the figure, it is many subconductors are linked using a spacer. That is what we call it as spacer. So subconductor 1, 2 and 3 are linked by using the spacer. Okay. So here conductors which are formed from 2 or more standard wire conductors bundled together to get more current carrying capacity of the system. So this is, it reduces the reactance of the transmission system. It also reduces the interference which happens in the transmission system. So this is highly preferred where high capacity is used. So coming to the assessment, an addition of 1% or 2% of cadmium to the copper, what happens to the tensile strength and the conductivity as conductor material? So tensile strength will increase, but the conductivity will decrease. So this is the, when we add cadmium material to the copper, either 1% or 2%, then tensile strength will increase and conductivity will decrease. So another question is, a stranded conductor has 3 layers of wire. Find the diameter of the conductor if the diameter of each strand is 5 mm. So for one strand which is 5 mm, then we have 3 layers, and the answer is 35 mm. So in this video we have clearly discussed about the transmission line parameters, basics of resistance, inductance and capacitance, and types of conductors, and a comparison between a solid, stranded and the bundled conductors. Thank you.